Right? So just trying to think about conversion from degrees to radians. So maybe I can write this function very quickly on my own here. And let me just make my adjustments. Right, so this is what I would like to make, this conversion. Sorry, what I need to do is, yeah, I probably need both, right, to do what I need right here. Of these functions, degrees to radians. Degrees to radians, so this one will take degrees as input. And the second function I need radians to degrees. Do what we can now. Degrees to radians would take pi times degrees divided by 180. And I think and likewise over here, radians to degrees, we can make is return degrees, which will be like 180 multiplied by radians and divided by pi. Right, so this is how the conversion works. So what is like 1 radian is about 157 degrees. Okay, so now that we have this, hopefully if this works properly, and let's just define pi. As a constant. Enough precision, I suppose. And so let's give it a try. So instead of using 100 over here, right? Instead of using let me just make this all visible. Instead of using for the sine function, instead of using the range from 0 to 100, I would like to use degrees instead. But in order to make these degrees, I want to use 360, like use a full circle, right? 360. But since the sine wants radians, I will take degrees to radians, like use this degrees to radians conversion that I just used, right? So now I don't need this comment because obviously we say, we take 360 degrees and convert them to radians. So this is just something that I wanted to try in this here thing, so that we can start controlling it with our application. So here you go. So this is one period, right? Like this sine curve that goes up and down right here. So, and then again, if we bring the scale to amplify it a little bit more, for instance, for the x-axis like this, and the x like this, and y like that, then we should get like more visible amplitude there, right? So this will be a good point to sort of like continue next week, right? So this is now being a little bit more amplified, more like articulate for one period of sine. So we need to continue this lab, of course, continue these exercises, and as we move along, we'll be going deeper into the internal structure, internal organization of the graphics library. And part of this discussion will be definitely conversation about C++ inheritance features, how these inheritance features allow us to construct individual concepts by combining our own concepts with already existing concepts. And so that will be essentially the focus of our discussion. But right now at this stage, we're going to wrap up today. I think that you have this perfect sandbox to play with examples from the book, like I tried to do today. So this is so far what I've been trying. This whole, of course, this entire coverage is to be continued next week. So thank you very much for your participation.